So in this first example, I know that A equals 2. I know that B equals -5, and I know that C equals 1. We're okay with that? So now I just sub these numbers into these two formulas you've just been given. So alpha plus beta, A, alpha plus beta, we know equals B over, negative I should say, B over A. Well, that equals negative, B is -5 over A is 2. Two negatives make a positive, so the sum of the roots here is 5 over 2. Is that okay? Just subbing the numbers into the formula. Well, that's nice and easy. I think question B is just as easy. We're just going to sub into the formula. So we know that alpha, beta, product of the roots is C over A. Well, I know that C is 1. I know that A is 2. And we're done. Nice and easy. Nice and easy. Question C though. C look a bit more confusing. Here is the trick. We have to, in order to find any variations or any of these functions, we've got to somehow be able to rearrange them into a form that we have an alpha plus beta or an alpha beta. So a sum or a product. We're going to have to rearrange it because at the moment we do not have a sum or a product of the roots. So how are we going to do that? Well, so we have 1 over alpha plus 1 over beta. How do you add fractions? Well, you first need a common denominator. So let's get a common denominator. What is the common denominator?
AB.
Oh, alpha beta. Do we know what alpha beta is?
Yes.
Yes, alpha beta is one of the things we want. So great. So I now have the denominator. Excellent. Okay. Well, to make this one, the first fraction over alpha beta, what do I need to times the top by?
Beta.
Beta. So here I have beta plus this one I have to times by alpha. Is that almost what we want? It is. Well, I could. Doesn't matter which one you add first. No, so I could have this as alpha plus beta over alpha beta. Now, are we in a form that we can get the answer for? Yes. So now I just sub in my formulas. Well, I already happen to know, I'm not going to redo it all, I already know what alpha plus beta is. I already know that it is 5 over 2. All over, I know that alpha beta is 1 over 2. And times top and bottom by 2, and it ends up with 5 over 1, or simply 5. The thing I find students struggle with the most is you get given a question, and the hardest part is to be able to manipulate what you're given into the form of it having the sum or the product of the roots. Okay? So basically the tips I'm going to give you in these few examples, there's 5 here, are basically going to cover all the different types of questions that you could be asked. The next one's a very important one. Have we got that written down? Can I rub it off? Yes? D is really important. Okay. D's, we are wanting to know alpha squared plus beta squared. Now, alpha plus beta squared, some students think it is this. actually though, what are
What is it?
I meant to do plus then. Plus beta. Is it that?
No.
It's almost though. Let me just show you a little aside.
Beta squared.
So let's just check out what is alpha plus beta in brackets all squared. Well, I know that it is alpha squared plus 2 alpha beta plus beta squared. Is it close?
Yeah.
This is the problem though. It's got this extra part.
So I can change that.
But this part in here is alpha beta. It's a product. So, coming back here, I can write it like this, but I have to take away 2 alpha beta.
Whoa.
If you can remember that,
You're a genius.
it's going to help you with so many of the questions that you'll do in the exercise. This one point, recognizing that if you have these added together, so alpha squared plus beta squared, we can write it as the square of the sums, but we have to subtract 2 lots of the product. Okay? Is that all clear? So, alpha plus beta. Now I just have rubbed it off. Can someone just tell me what was alpha plus beta? We worked it out a moment ago. 5 and 2? 5 on 2, and that's going to be all squared, minus 2 times, this was a half, wasn't it?
Yeah.
Okay, well, this becomes 25 over 4 minus, well, this is minus 1, right? So the final answer becomes 21 over 4. You could, of course, put that part straight in your calculator just so that you don't avoid any silly errors and you get the number correct at the end. So you could have it right at this point, put it in your calculator. I just did it in my head. Does that make sense? But you would, the thing that you'd get stuck on is this step here. So keep that in the back of your mind, and when you get stumped on a question in your exercise, come back to that step. Okay, E. Part E, we have alpha minus 1, beta minus 1. Well, why don't we expand it out and see what we get? Let's expand it. So we have here alpha, beta, minus alpha, minus beta, plus 1. Can I put this in a form of either sums or products? Yes, I could do this. Alpha, beta, plus, so no I'm not, I'm going to minus, alpha plus beta plus 1. Now I have it in the form of a product minus the sum plus 1. Is that okay with you? Follow what I've done? Because don't forget when you expand out the negative, that will make both alpha and beta negative. Well, I'm now ready just to sum in the numbers. We've already worked out what alpha beta is. Alpha beta was 5 over 2. Right. You're right. Thank you, I'm muddling them up. Minus this, the sum was 5 over 2, wasn't it?
Yeah.
Okay. So we have a half, minus 5 on 2, which is negative 4 on 2, negative 4 on 2, which is the same as negative 2. Negative 2 plus 1 is negative 1. You could, of course, just put that straight. If I were you, and even myself, if I was in a test, because you know when you're in a test situation and your brain's just not thinking clearly and you don't want to lose mark, for knowing the concept and just making some little stumble with the numbers. I would, in the test myself, I'd put that number straight in the calculator and let the calculator give you the answer. Just remember, whenever you do, if there is a negative sign, as there was with the first one that we did, just put the negative in brackets, okay? Because that does change things. Is that all good? Excellent. Let's scroll down. So this one says, find the quadratic equation with roots, and we're given the two different roots. So there's two different methods you could do, and I'll show you both the methods and you can see which one you like better. The first method won't involve what I've just taught you. Okay? The second method will. So for question 2, we'll do method 1 first. Method 1. So if they're the roots, we could just say that this is x minus 2 plus root 5. Then multiply that by x minus 2 0. So all I've done is I know that the roots, I've done this. X minus alpha, x minus beta equals 0. So I know that the roots, one of the roots is negative 2 plus root 5, and I know the other one is negative 2 minus root 5. So I've simply done that. I've just subbed those two roots into this. Okay? Now I'll just expand out the brackets and I have x plus 2 minus root 5. And then over here I have x plus 2 plus root 5. Okay? Now, to make life just a little easier, we could just put brackets around this, and when we expand that out, just expand it out as a quadratic, rather than having 3 terms and multiplying it all out. It'll just make our life slightly easier. So multiply, let's do the FOIL method. X times x is x squared plus 2 plus root 5 plus root 5x plus 2 minus root 5x plus, I'm multiplying them together. So 2 minus root 5, 2 plus root 5. Okay? Okay with that? Why am I making it more complicated?
It makes sense.
Yeah. Notice anything with that? What is it?
Difference of
Difference of 2 squares. So this becomes x squared plus 2 plus root 5x plus minus root 5x plus 4 minus 5 0. Yeah? 2 squared is 4, root 5 squared is 5. I'll just expand out the brackets now. We have x squared plus 2x plus root 5x plus 2x minus root 5x. What's 4 minus 5? Can I cross anything off? I could. Root 5's gone. Can I collect anything? I can put the two x's together. So now I have x squared plus 4x minus 1 equals 0. Oh look, it was such a lovely quadratic. We had to go through all of that effort to find out that it was simply x squared plus 4x minus 1 equals 0. Okay with that? I'll just give you a moment to copy it down. Sing out if there's any line in that doesn't make sense. Okay. Are you ready for me to rub it out? Yeah? Now, I think you're going to like method 2 so much better. Let's see.
I'm going to say 2 separate bubbles.
Method 2. We're going to use roots. So I'm going to say, let alpha and beta be the roots. So if alpha and beta are the roots and we have those are the roots, I know that alpha plus beta equals, I'm just going to add them together, negative 2 plus root 5 plus negative 2 minus root 5. So I'll just add them together. So I now have negative 2 plus root 5 minus 2 minus root 5. Can I cross anything out? What can I cross out? Root 5's gone. Can I collect any terms? Minus 2. So I now have that's minus 4. We okay with that? All I've done is I've added, we're told that these two are the roots, so I've just added the two roots together. Nothing else. Now let's just find the product. Alpha, beta equals minus 2 plus root 5, minus 2 minus root 5. We see the difference of 2 squares. So if we see the difference of 2 squares, it's going to be 4 minus 5, which equals negative 1. So we've got the sum, we've got the product. Now, just a moment ago, we said that x squared plus alpha plus beta x plus alpha beta equals 0. We worked out that that's the roots. And that's the equation and the relationship between the equation and the roots. And I happen to know now what alpha plus beta is. I just know that that is negative 4. So that's plus negative 4, which is just going to be minus 4x. That doesn't look like a square. Let me fix that up. Make that squared. And I know that alpha beta that should have been, yeah. I did this wrong. That should have been a minus. So then minus that, then becomes a plus. That's where I went wrong. Now they should be the same. Are your equations the same?
Yeah.
Which method do you like better?
One.
You like one? Still better. Oh, you could do one. Doesn't say you have to do one way or the other. So as you get more comfortable with these roots, sum of products roots, you may or may not like that better, but anyway. Okay. We have two more. Two last roots. Okay. So question 3. Question 3 isn't as hard. Question 3 says, find the value of k in the equation, kx squared minus 5x plus 4k equals 0, when 4 times the sum of the roots is equal to their product. Okay, well I know that, what's a in this case? A equals, what's the coefficient of x squared? K. A is K. What is B? Negative 5. And lastly, C, which is the constant term, is 4K. So I know that much. So what we are told is that, question 3, we are told that 4 times the sum of the roots is equal to their products. In other words, 4 times by the sum of the roots is equal to their product. Okay, well, the sum of roots. Go back to your notes. Go back to the notes. Kai, what's the sum of the roots in terms of A's and B's and C's? What's the sum of the roots? Okay, someone's got it. What is it? Negative B over A. Now we know that. Equals, and this one is C over A. You want to have it accessible, maybe highlight, put a box around in your book because you're going to be going back to that many, many times until you have these, so you're going to have them by memory very soon. Okay, well, I have all of that. I have what A, B, and C are, so I'm just going to sub them in. 4 times negative, B is negative 5, so negative 5, which will become positive 5, over A is K, equals C was 4K, A is K. By the way, the K's are going to cancel off and leave me with a 4, which will be nice. So now that's 4 on this side. The two negatives on the other side, minus negative 5, that just becomes 5. So I have 4 times by 5 over K. That. Getting pretty close here. 5 times it by 4. 4 times 5 is 20. So that's 20 over K equals 4. What about if I multiply both sides by K? 20 equals 4K, and I think you can see the last step. What does K equal? K equals 5, and we've just worked out the problem. K equals 5, and we're done.
That's cool.
It sounds scary and hard, but that's actually fairly straightforward. So if you use the sum and product of the roots, it's not that hard. The next one is very similar. It's not going to be that hard. Find the value of P if one root of this equation, x squared plus 2x minus 5p equals 0, is double the other root. Well, let's first find out our A, our B, and our C. What's A this time? 1. B, the coefficient of x is 2. C equals minus 5. did the question say? One root is double the other root. Okay with that? Great. So now we'll just put in what we know. Find the value of p. One root is double the other root. Well, let's start with the sum of the roots. Alpha plus 2 alpha. What's the sum of the roots? Sum of the roots is minus b on 2a. Minus b on a. Sorry, same. So, minus b is minus 2. Minus 2 on 1. On the other side, we have 3. So, in other words, 3 alpha equals negative 2. So, what's 1 alpha?
2 and 3, and therefore 2 alpha is double that.
So then the other root is going to be negative 4 on 3. Therefore, the roots are minus 2 on 3 and negative 4 on 3. So you've got the two roots. Now, we could then find out what p is from there. So it says find the value of p. Well, p comes up in the product of the roots. So minus 2 on 3 times by minus 4 on 3. The product is going to be c over a, right? C is minus 5p, a is 1. Multiply them together, 2 times 4 is 8 over 3 equals minus 5p. So in other words, divide both sides by negative 5. We have p equals 8 over 15 and it's a negative. I just divided both sides by negative 5 and I found p. Am I done?
Are you done with your jobs?
I am done. So that's all of the exercises there, examples.